Get started on our Chapter 10A review. Starting with number 1, this question is worded a little bit weird, but basically wanting you to think through when you're looking at two lines on a graph, what is going to happen? When do you know there is a solution? What is it? What happens if you have the same slope of two lines? What happens if the lines are on top of each other? What are your solutions looking like? So for A, what is the solution when the two lines intersect at one discrete point? Well, there we go. So if we have two lines on a graph and they're intersecting at one discrete point, what you're looking for is that is a solution. If you were to have these two equations of the two lines, you could use substitution or elimination, and you would be solving for x and y, and this would be your actual solution. What's the solution when the two lines have the same slope? So if we have two lines, here they have the same slope, well, they're never, ever, ever going to intersect because they're parallel. Whoa. So therefore, there is absolutely no solution. They will never touch, they will never intersect each other, therefore they will never come up with this discrete point. What is the solution when the two lines coincide and intersect at infinitely many points? So when it's coinciding, change this. That means that the lines are directly on top of each other, which means that every single point is a solution. And if you can continue to keep going and going, you have your infinitely many solutions. All right, so moving on to number 2. Solve the linear system. We're going to be using two variables and we want to solve by hand. This is just kind of breaking the information down for you, making sure you're understanding what you're actually doing as you're solving by substitution or by elimination. So to solve the system by substitution, which expression could be substituted for y in the first equation? So we want to figure out then, we want to take a look at the second equation. We want to get y alone. So we know if we were to use substitution, what could we place into this variable right here? So I'm going to just solve for y here. 2y equals, now I'm moving over negative 3x minus 2. Divide everything by negative 2. So y equals positive 3/2 plus 1. So this is what I would substitute into the first equation if I was going to solve this system by using substitution. If the first equation of the system is multiplied by 3, by what number would you multiply the second equation to eliminate the x variable? So this time we're going to be looking at this first equation. And the first thing I'm going to do is exactly what they say. Multiply that first equation by 3. So I have 3 times 8x plus 16 y equals 16. Okay, so I'm going to distribute everything. This is going to turn into 24x plus 48y equals 48. Okay, so now the remaining part of the question is what number would we multiply the second equation in order to eliminate the x variable? So since I multiplied this by 3, I now need my first term here to turn into 24. But I need it to eliminate, so since this is positive 24, I need this to actually turn into a negative 24. So that's meaning I need to make sure I am multiplying my second equation by negative 8. I'll just double check everything. Okay, so if I have negative 8 times 3x minus 2y equals negative 2, this would turn into negative 24x plus 16y equals 16, and therefore these would then cancel out. So your answer here is negative 8. All right, and so here now we actually want to solve the system by hand. And what I'm going to do here is I'm just going to take this work right here. Okay, so here now we have our x's actually did cancel out. So I'm going to add these up. So I have 64, y equals 64. So when I'm solving for y equals 1. Okay, now I can take this and I can plug it into the other equation and solve for x. So here we have 8x plus 16 times 1 equals 16. So 8x equals 0, because 16 and 16, those are going to go away. So x equals 0. So my final solution is 0, 1. Alrighty, so moving on to our application problem. Bill and Steve decide to spend an afternoon at an amusement park, enjoying their favorite activities, the water slide, gigantic Ferris wheel. Their tickets are stamped each time they slide or ride. At the end of the afternoon, they have the tickets as shown below. How much does it cost to ride the Ferris wheel? So I would say think of the water slide as your x, and think of the Ferris wheel as your y variable. Here's your two different variables. Okay, Bill's ticket adds up and has a total cost. Steve's ticket adds up and has a total cost. And they both ride these same rides. So we can set up this equation. Here we have Bill, and here we have Steve. So he rode the water slide 3 times, so we have 3x plus Ferris wheel 3 times, 3y, and his total amount was $17.70. And then Steve decided to ride the water slide only 2 times. He rode the Ferris wheel 3 times, and then his total amount was $15.55. So now we can use substitution or elimination, but really the easiest thing to do here, what I'm really looking for is you guys to set up these equations and then plug it into your Inspire and solve that way. So once you do that, you would figure out that x would be $2.15 and y is $3.75. Wow, I am very messy on here. I apologize. And we're actually looking for, this is the water slide, this is the Ferris wheel, and what we're asking is how much does it cost to ride the Ferris wheel? So my final answer is $3.75. All right, I'm going to now make a new video for the next page.